Okay, assignment 1. Uh, these are the answers. You should have tried all these problems. Um, some of these have multiple answers. I go the point slope form as much as possible, please. I'm telling you, it's worth it. There's a big reason. So if you need to, you can pause this and then write down. Now, these vertex roots, find the roots. That's x-intercept. So set the equation equals 0 and solve. The vertex, I want to use that new trick I showed you in the notes. Don't use the formula from algebra 1. Don't use x equals negative b over 2a. Use the derivative equals 0 and solve for it. So back, I have some absolute max min questions at the top. You should have tables, and you should have work like I showed you guys in the notes. 13, 14, 15, 16 we did together. 13, 14, 15. These are optimization problems. I'd like justification, tables, critical points, endpoints. There's a bit of work to go with these. This is just the most basic parts of the answers. So if you create variables and there weren't variables, then it might not be appropriate to put those variables in the answer. Someone might use the same variables in different places. That could be confusing. So let's try these out. So find the equation of a line through 2 points. Well, you need two things to write the equation of a line. You need a point, which we have 2 of, and the slope. So we need to find the slope by doing rise or run. Change y. 11 minus 5, negative 1 minus 2. You just need to be consistent. You can start with either point. You just need to be consistent. If you go one way, you get positive 6 over negative 3. If you go the other way, you get negative 6 over positive 3. In the end, it's still negative 2 for both of them. So then you can write the equation in line and point slope form. You can do y minus 5 equals negative 2, x minus 2. That's good enough. Done. You could do y minus 11 equals negative 2 times x plus 1. Sure. Okay. Use the other point. You could change either of these in the slope-intercept form, and you'll get the same answer either way. Either one of them. They look different in point slope, but in slope-intercept, they'll come out the same. But that's unnecessary, so I wouldn't be doing it. Find the equation of a line that's perpendicular to this line. So you have a point, you need a slope. The slope's going to come from this perpendicular relationship. So you got to figure out what the slope of this line is. So 3y equals negative 2x plus 6. Divide both sides by 3. Y equals negative 2/3 x plus 2. This is really what we need. So the perpendicular slope to this is going to be positive 3/2. So the equation of your line is going to be y plus 3 equals 3/2 x minus 2. That's good enough. I would just leave it. If you do decide to go to slope-intercept form, you get 3/2 x minus 3 is minus 6. That's okay also, but unnecessary. Find the slope and y-intercept of this line. So I think the easiest way is to go ahead and change this to slope-intercept form. So y over d equals negative x over c plus 1. Multiply both sides by d. And so we get y equals negative d over cx plus d. So the slope is right here, negative d over c. And conveniently, the y-intercept is right here. So there's an example of changing it to slope-intercept form and it being useful for something else. So for problems 1 and 2, that didn't help. Classify these lines as parallel or perpendicular. So if you're going to decide 2 lines are parallel or perpendicular, it's really about their slopes. So I would go ahead and change these to slope-intercept form. 3y equals 5x plus 6 divided by 3. You got to have work. to convince me. I mean, if you try and do this on your head, okay, I don't know. It seems like that's going to lead to some mistakes. And I just don't think it's worth it. And if you make a mistake, then you can't get partial credit on my test. So probably won't show work. Okay, so I have the same slopes. So they are parallel. Okay, find the equation of the tangent line and the normal line. Now, we talked about this in notes. It's really the same amount of work for both, the same work for both. So we're going to go and use a little calculus here. We take the derivative. Power rule is going to be 3x squared. The derivative plus 1 is 0. We're going to plug 2 into it. And we're going to get 12. So that's your slope. That's your parallel. That's your tangent line slope. And you also need a point. So we're going to plug 2 into the original equation. There's a plus 1 there. So that's going to be 9. That's your y value. So your point is 2 comma 9. You can write the equation now. Just do point slope form. So for the tangent line part A, it's y minus 9 equals 12x minus 2. And for part B, it's a normal line. It's y minus 9. It's going to the same point. The slope is negative 1/12 because it's perpendicular to the tangent line. The derivative gives you the slope of the tangent line. There you go. Find the point of intersection of the tangent lines, two different tangent lines on the same curve. So we got to find, I think we got to find the equations of the two tangent lines first. So we got to find the slope of each. So that's the slope of that one. And when you plug 2 into that one, you get 9. So your point is 2 comma 9. So I think that's the same as the last problem. But then, and so then you could write the equation of that tangent line be y minus 9 equals 12 times x minus 2. And I think on this one, change it to slope-intercept form does have its benefit. So I'm going to say y equals 12x minus 24 plus 9 is going to be minus 15. So that's our first tangent line. Our other one, we got to do, it's the same derivative, y prime, but at a different x value. So plug 1 in to the derivative, and you get that for your slope. It has a different xy pair. Plug 1 into the original equation, and you get 1 comma 2 for the point. So then the tangent line is going to be y minus 2 equals the slope 3 times x minus 1. I'm going to go ahead and change that to slope-intercept form. So it's going to be 3x minus 3 plus 2 is minus 1. So far we just found the two tangent line equations. So now we're going to find the intersection of them. Now this is just a system of equations. So algebra 1. These are set up, I would say, nicely for substitution, where you plug this in for the y of the other one to get rid of one of the variables. When you solve systems, it's all about trying to get it down to one variable. And then solve for x. So x equals 14/9. You got to find the y value still. So you could plug this into either one of these equations. Doesn't matter. I think this one just looks a little simpler. They're going to give you the same answer because this is the intersection point. They should. I guess it's a good way to check your work. If you're going to plug in both, they should both give you the same y. 14/3 minus 3/3 is 11/3. So the intersection point is an ordered pair. X first, y second. I mean, you could write it as 1 5/9, comma 3 2/3 if you want. Either way. Okay. All right. Oh, I guess I skipped parts on number 4 and 5, so I'll do those right now. Number 4, are these parallel perpendicular? Let's get the equations into slope-intercept form. And let's see, this one I'd add the AY to the other side to get Y by itself, but make it positive because that's more convenient, less messy. Okay, so it's the slopes that matter. Since these slopes are negative reciprocals, if you show the same thing upside down, different signs, they are perpendicular. Okay, gotta give me some evidence. So this one we're trying to find tangent and normal lines for these equations also. So we gotta do y prime equals 2x minus 1 derivative of plus 2 is 0. Derivatives are measuring change of something. If it's just 2, it's not changing. I'm going to plug negative 3 into the derivative to get the slope. We're going to plug negative 3 into the original equation to get the point. Now be very careful here. You'll notice I'm very careful at putting things in parentheses. So it's going to be positive 9 plus 3 plus 2 equals 14. That's your y value. So the point is negative 3, 14. So the tangent line, part A, y minus 14 equals negative 7, x plus 3. Point slope, good enough, done. B, y minus 14 equals positive 1/7, x plus 3. Same xy pair, slope is perpendicular to the tangent line slope. Okay, so next one, y prime equals 4x cubed plus 2x, y prime 0, plug 0 in. Slope is 0, interesting, flat line. Plug 0 into the original equation. Gives you 2. So the point is 0, 2. So the tangent line has a slope of 0. I mean, you could do point slope form y minus 2 equals 0 times x minus 0, and that's fine. You could simplify this very nicely into y equals 2, which is a horizontal line that has the same y values the whole time, which makes sense. It has a slope of 0. The perpendicular one would be y minus 2 equals, well, what's 0 flipped upside down? Change the sign. Well, this is undefined. Can't divide by 0 in math. You can't just write the word undefined in it, so this whole idea just doesn't work. The perpendicular slope would be undefined. It's going to be a vertical line, okay? And how do we write the equations of vertical lines? Learn back in Algebra 1. X equals a constant value, 0. So that's the normal line is a vertical line. Can't write vertical lines in slope-intercept point slope form. Okay, now for these down here, I said I wanted you guys to use calculus to find the vertex. Now the roots are just the x-intercepts. So you just set y equal to 0 to find x-intercepts, and you factor to help if possible. So x equals negative 3 and negative 1 are the roots. Okay. And the vertex, I don't want to use the formula from Algebra 1. I want you to do derivative equals 2x plus 4. The slope has to be 0 at the vertex. So set the derivative equal to 0 and solve. Now that's the x value. So you still need the y value of the vertex. So that's positive 4 minus 8. It's negative 4 plus 3 is negative 1. So negative 2, negative 1 is the point. That's the answer. That's the vertex. Okay. Same thing here. Set y equals 0. Now we can't factor it this time. You can try, but it's not going to work. So we're going to say equals 0. We're going to solve it by quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So that's going to be negative 6 plus or minus 36 minus 8 is 28. You take the square root of 4 out. You divide everything by 2. You got to distribute it, though. You can't just divide that by 2. This has to be divided by 2 also. So we get 2 answers, and these are the roots. And they're real. So then the vertex, y prime equals 2x plus 6 equals 0. 2x equals negative 6. X equals negative 3. Plug in negative 3 into the original equation. It's good to label your work. Okay, I don't want to see random numbers and expressions without any kind of label as to what they are. Let's see. 9 minus 18 is negative 9, plus 2 is negative 7. So negative 3, negative 7 is the vertex. So this is the way I want you to find the vertex, okay? We're using a little bit of calculus right now. Okay, this one right here, if we set it equal to 0, we would have to use quadratic formula. X equals negative b plus or minus the square root b squared minus 4ac over 2a. And these are your roots. So quadratic formula, because this is sort of the most generic standard way of writing equation parabola, quadratic, a x squared plus bx plus c. That's what the quadratic formula is based off of. Then we're going to do y prime equals. Now the a and the b are just numbers. So if this 2 comes down, 2a x to the first plus b x to the 0, which is, and then c, the derivative of c is 0. And we set it equals 0. We get 2ax equals negative b. X equals negative b over 2a. That should look familiar. Okay, then we got to plug that back into the y equation to get the y coordinate. This is where it gets a little messy, but you guys can do it. Negative b over 2a squared plus b times negative b over 2a plus c. We could, let's see, give these guys least common denominators. This one has a 4a squared. This one is 2a, so this needs an extra 2a, top and bottom. This one needs a 4a squared. So we get we get positive ab squared over 4a squared minus 2ab squared over 4a squared plus 4a squared c over 4a squared. So final answer for the vertex is negative b over 2a for the x. The y, this simplifies a little bit because there's, let's see. Negative of 2a squared. Oh, okay. We could reduce all these. We could, we can make this a little nicer. We could take an a out of the top and bottom, a out of the top and bottom, 1a out of the top and bottom. So then it's b squared. It's 4ac, 1b squared minus 2b squared is minus 1b squared over 4a. So this would be the simplest answer for a very messy answer. So there you go. On to the back. So on the back, we're doing a little calculus at the top. Finding max mins. These are absolute max mins. we have endpoints, which you need to check, and we got to find critical points. That's where there's peaks and valleys. We got to check those. So the way we find those is like the same way we find vertex on parabolized. We take a derivative, and we set it equal to 0. -4 divided by 2 is -2. So this is a critical point. So I need this work. The derivative equal to 0. Find this point. So then we make a table. And we plug these. It's kind of a simple idea. It's like, well, it could be the edges or it could be the peaks and valleys in between. Check them all. So we check them all. So if you plug -2 in here, you get 100 minus 40 minus 12 is 48. Plug -2 in, you get +4 minus 8 minus 12 is -16. And you plug 10 in, you get 100 plus 40 minus 12 is 128. So there's the max, there's the min. And when we write these answers, I want them written like this. I'm going to say these are absolute. If you don't see the word absolute, that means absolute still. Okay? So we say the max is 128 at x equals 10. And we can go and lump these together. The min is -16 at x equals -2 by extreme value theorem. That's what we're using. I want you to start writing this. You're going to have to write this on free response problems. Might as well get started. Just do it all year by checking endpoints and critical points. So I want all this for full credit. Okay. Next one, y prime equals 4x plus 1 equals 0. X equals -1/4 is your critical point. Make a table. -10, -1/4, +10. Plugging them back into the original equation, not the derivative, the original equation. So you plug -10 in here, you get 100, you get 200 minus 10 minus 15 equals 175. Plug -1/4 in, it's a little more complicated. It's going to be 1 + 1/16 minus 1/4 minus 15. So we should try and simplify this, I guess. That'd be 8. These come down, maybe 2, or it'd be 8. So that's -120, -122, -123 over 8. Or we could write it as -15 3/8. 10 is going to be 200 plus 10 minus 15 equals 195. So there's your max. There's your min. Okay, so we're going to say the max is 195 at x equals 10. The min is -15 3/8 at x equals -1/4 by extreme value theorem. How does that work? By checking endpoints and critical points. So this is required stuff in the AP exam. There's going to be plenty of other required stuff that we're going to spend all year covering, so you might as well get the hang of this right now before we add more stuff. Okay. y prime equals negative 2x plus 8 equals 0. X equals negative 8 divided by negative 2 is positive 4. That's your critical point. We're going to make a table. Negative 10, 4. So we're using the same endpoints for all these. So that's going to be negative 100 minus 80 minus 12, negative 192. Plug 4 in, it's going to be negative 16 plus 32 minus 12. Negative 28 is 4. Plug 10 in, you get negative 100 plus 80 minus 12 is negative 32. So here's your max. Here's your min. You can write the answer. The max is 4 at x equals 4. The min is negative 192 at x equals negative 10 by extreme value theorem, checking endpoints and critical points. All right. Now for the next ones that are like this, but a little harder. Okay, so for optimization, rectangular fence, 100 feet, joins the river as shown. Find the dimensions of the rectangle with the largest area. So the river is a natural boundary, so we don't need to build fence there. We have 100 feet of fence. That's going to be a constraint, like a perimeter constraint. We got to create some variables. These sides are going to be equal. It's rectangular. I'm going to call those x and call this one y. You could go the other way, but that's why I probably shouldn't put x and y in my final answers. So step number 1, find a formula for the thing you're trying to optimize, maximize, minimize, the area, x, y. Step number 2, get it in terms of one variable. So that's where the perimeter comes in. There's 2 x's and 1 y for fencing, which adds up to 100. So then we could solve for y in terms of x or x in terms of y. I'm going to go y equals 100 minus 2x and plug that into the other equation to get it in terms of one variable. Okay, so now I have an equation in terms of one variable. That's a bunch of geometry work. Okay, maybe go ahead and distribute it. Now we need to find endpoints and critical points. So critical points are going to come from the derivative equaling 0. So x equals 25 is your critical point. Endpoints are going to be what are the smallest and biggest values of x. If you solve for x in terms of y and get everything in terms of y, then you pick an endpoints for y. Now, it generally can't have negative fences, so 0 is a good idea. Can we build 0? Sure, this fence will all be right up against the river. It seems kind of dumb, but it is possible. The other scenario is what's the smallest y could be? Well, I think y could be 0, and then you use all your fencing for x, which it could be the biggest x values, which would be 50. It would just split that, but the two fences would be right up next to each other, which seems kind of dumb, but it is an endpoint. So these are your endpoints. So then we're going to create a table like we've been doing on the other problems. X area, x 100 minus 2x. I like using the factored version for my tables. It just makes it work easier to do in my head. 0, 25, 50. So 0 times 100 is 0. 25 times 50 is 125 with a 0 on it. 50 would be 50 times 0 is 0. So these are your min. There's actually a tie for the min, and this is your max. And we're trying to find the largest area. So now we're going to write our answer. We're going to say the largest area is 1,250 square feet, my units, when instead of saying when x equals and y equals, by the way, this is your y right here. So that's another reason I like using the factor version is it makes x and y very obvious. You don't have to go back up here and use it to find the y that goes with it. It's in your work. But someone could have put x here and y is there. So x and y doesn't really mean anything unless it was already in the problem, which it wasn't. So instead of saying x, I'm going to say when the sides perpendicular to the river are 25 feet and the side parallel to the river is 50 feet by extreme value theorem, checking endpoints and critical points. So this is the way I want checking endpoints and increment. This is the way I want you to write your answer. You use units, tell me what the max or min is, tell me where it happens, justify your answer, extreme value theorem, checking endpoints, critical points. So this is the answer I'm looking for on these kind of problems. Okay? On your next test. Rectangular plot of land is enclosed by heavy fencing, $5 a foot on two opposite sides, $4 a foot on the other sides. So this is kind of like that example we did in the notes where there's heavier fencing, which you might go ahead and make dark. Now, we don't really know if those are longer sides or not. That doesn't matter. This picture is really just to help me organize everything, create some variables, keep track of stuff. So this is $5 a foot, $5 a foot. These are $4 a foot and $4 a foot. I find this helpful just to help avoid mistakes. Now we got to create some variables. Find the dimensions with the greatest area for a cost of $1,000. So this is our constraint. So there's usually some other constraint which we're going to use to help us find an equation in terms of one variable. So I call these x, call these y, because it's a rectangle and their opposite sides are equal. Could put x is here and y is here. That's why I'm probably not going to use x and y in my answer. I'm going to talk about heavy fencing. So the thing we're trying to maximize is area, which is going to be xy. So that's your first step. Then we got to use cost, which is going to be 5x plus 5x plus 4y plus 4y adds up to 1,000. Okay, so now you could choose to solve x in terms of y in terms of x. Doesn't matter. You get the same answer in the end. The work's going to be a little different along the way. You could simplify this. So I'm going to go ahead and solve for y in terms of x. So 8y equals negative 10x plus 1,000. And you can divide by 8. I don't think there's any way to avoid fractions on this one. Sometimes you might choose your x or y. Choose to solve for x or y depending on the niceness of the results. But it's going to be 5/4 x plus, that's 4, that's 500, that's 250, that's 2, that's 125. So then we're going to plug that in here. And I find it helpful to circle these important things, show little arrows, show what you're doing with them. So your area formula is now x times negative 5/4 x plus 125, or negative 5/4 x squared plus 125x. Now I like this equation for my table. I like this equation for doing my derivative. Y prime, negative 5 halves x, because you're going to multiply by 2, which reduces with 4, plus 125 equals 0. So 5 halves x equals 125. X equals times 2/5 times 2/5. So 5 goes into 25, so that's 50. That's your critical point. Then you got to figure out your endpoints. What's the smallest x could be? It could be 0. The biggest x could be would be the smallest y, which is when y equals 0. So that's going to be, I think that's going to be, so you're going to take this equation right here and solve for x. So that's going to be 5/4 x equals 125. We're going to multiply by 4/5. So that's going to be 100. So that's 100. These are your endpoints. So, okay. So now we're going to make a table. Okay. I'm going to make a table. I'm going to make, so I got this in X. So area equals X negative 5/4 X plus 125. I like that factored form. Our endpoints are 0, our critical points 50 and 100. So you plug 0 in here, it's going to be 125, which is 0, which makes sense. It's kind of like a stupid fence because it's like they're right next to each other, but it is a possibility. Plug 50 in, you get 50 times. This is going to be, let's see, negative 250 over 4 plus 125. That could be 125 over 2. So it's going to be 50 times positive 125 over 2. That's going to be 25. So it's going to be kind of a large number, it seems like. 25 times 125. 5 times 5, add 2 to 10. 12, add 1 to 5 is 6, 0. 10, add 1 to 4 is 5, 1. 5, 2, 11, 21, 25. 100 is going to be 100 times, you plug in here is 25 times 5 is negative 125 plus 25 is 0. That's that other kind of. So here's your max. There's a tie for min, which is not what we're looking for, but that the work is in there. So we're going to say that the greatest area is 2125 feet squared when the heavy fencing is, that's the X values of mine, 50 feet each, and the other fencing is, what would it come out to be? 125 over 2, so 62.5 feet. By extreme value theorem, checking endpoints and critical points. Okay? All right. Sorry, squeezing a lot of work in here. So that's the answer. Okay. One last one. Find the dimensions of the lawn with the greatest area. Sounds similar. Here's a lawn. We don't need to build a fence next to the house. We have 200 feet of fence. So this is a perimeter constraint. We're trying to get the greatest area. All the fencing is this, same thing. So I'm going to call these X and X. I'm going to call this Y. So this whole thing is Y, but that means this fence right here is Y minus 50. So the area is XY, and then we need to use the perimeter to help us. The perimeter is going to be 2X plus 2Y minus 50 if you add up all the fencing, and it needs to add up to 200. So then we can solve for Y in terms of X or X in terms of Y. So I'm going to go with just getting Y in terms of X, not because I have to. So I'm going to add the 50. I'm going to subtract the 2X. I'm going to divide by 2. So X equals 125 minus X. I'm going to plug that back in up here to get my equation in terms of one variable, X times 125 minus X. So A equals 125X minus X squared. Then I need to find a critical point, so I got to take the derivative and set it equal to 0. And we get X equals 125 over 2. That's your critical point. We got to get endpoints. Smallest X would be 0. That is possible. What's the biggest X could be? Well, Y could be 0. Nope. If Y is 0, you get a negative fence there. Smallest Y could be is 50. So we set Y equals 125 minus X to 50, and we get x equals 75. So the biggest x could be is 75. So that's where things get a little tricky sometimes on these endpoints. Some people have trouble. You got to make sure that it's realistic. You can't build negative fences and like magically have more fence, and that's not possible. So these are your endpoints. Okay, so then we're going to make a table. And I like to use the factored version for my table. The simplified version is easier for the derivative. Plug your endpoints and critical points in. And so that's going to be 0 times 125 is 0. So it's kind of silly because the fencing all right up against the house can't contain anything. And then 125 over 2 times 125 minus 125 over 2. So that's going to be 125 over 2 times 125 over 2, which is some gross number, but we'll try and find it. 5 times 5 is 25, carry the 2, 10 is 12, carry the 1, to 5 is 6, 0, 10, carry the 1, to 4 is 5, 2, 0, 0, 5, 2, 1, 5, 2, 16, carry the 1 to 4 is 5. So it's 15, 625 over 4. Ugh. Plug 75 in. 75 times 50. So 5 times 75. And then I'll just add a 0. 25, carry the 2 to 35 is 37. So it's going to be 3750. Now, I just got to figure out if this one's bigger. So I'm going to do a little long division. 15, 625 divided by 4 goes in 3 times. 12, 36 is 9. 0, 2, 0, 25, 6, 24, and 1/4. Okay. Ooh, that one is barely the max. Okay. So this is the min. This endpoint is really close, but this ends up being the max. So we're going to say the greatest area, which is another way of saying maximum, opposite maximum, is 3906 and 1/4 feet squared when I don't know how to describe this. Let's see. When the side next to the house is 62.5 feet, and the side opposite means across from, opposite the house is the same thing. Wow, that's kind of interesting. 62.5 feet. That little side right there is going to be 12.5. So, but I think, that's the dimensions. By extreme value theorem, by checking endpoints and critical points. All right. So yeah, these are definitely challenging problems, word problems, making you think. Got to think, got to justify your answer. So there you go. We'll have more opportunities to practice these, but a little bit of calculus in there. Kind of a base, kind of a very common calculus idea that you should got to check the edges and the high and low points, and we identify the high and low points by figuring out what the slope is 0. So there you go. And we did 16.